Today, we're not just taking a standard run-of-the-mill science tour. We are stepping directly into the middle of literally the greatest unsolved mystery in the entire cosmos. I mean, our knowledge of the universe has absolutely exploded in recent years, right? But what scientists can actually observe, touch, and prove for sure? Well, it's just a remarkably tiny fraction of what's actually out there. So get ready, because we are hunting down two totally elusive phantom forces that basically dominate the very structure of space and time.
Look at this staggering number, 95%. 95% of our universe is completely, totally invisible to us. Just let that sink in for a second. Every single star you've ever looked up at, every planet, every galaxy, your own body, the exact device you're using right now to listen to this, everything we have ever known or seen makes up a ridiculously small exception to the rule. We are literally flying blind to almost everything that exists.
So here's how this whole cosmic crime scene actually breaks down. That tiny 5% sliver, that's standard, regular matter. That's us. Then a much larger chunk, around 23%, is what we call dark matter. And then there's the massive remaining 72%, which is known as dark energy. And by the way, just a quick aside, scientists use the word dark not because it's literally black in color, but it's basically a placeholder for we honestly have no idea. It just means it doesn't interact with light, and we don't know exactly what it is or where it comes from. Section 1, Suspect 1. Dark matter. The invisible scaffolding and ghostly glue that holds galaxies, like our very own Milky Way, together. See, our galaxy is surrounded and permeated by a massive accumulation of this stuff. And without it playing a decisive role, galaxies like ours would literally spin themselves apart and just fly off into the void. There's no way they'd hold together. But let's look at how this investigation actually built up historically, because it definitely didn't start yesterday. Back in the 1920s, Edwin Hubble discovered that the universe was expanding. Then skip to 1933, and a rather curmudgeonly physicist named Fritz Zwicky was looking at the Coma cluster of galaxies. He realized something wild. They were moving way too fast. Based on the visible matter, they should have completely broken free and scattered. So he proposed there just had to be some unknown invisible mass keeping them all clustered together. But it actually took all the way until the 1970s for astronomer Vera Rubin to analyze the blazing orbital velocities of stars in distant galaxies and mathematically prove that, hey, Zwicky was right all along. And you know, this brilliantly illustrates the human side of science. When Zwicky first published his findings, his peers basically ignored him. They completely dismissed him, saying things like, "Oh, Fritz, leave him alone, he's got another nutty idea." His discovery just did not fit the established views of the time. And Vera Rubin, she had to fight tooth and nail for recognition in an incredibly male-dominated field. The men had already claimed the inner, much easier to see parts of galaxies, so she had to study the really difficult outlying areas. But guess what? That is exactly where she found the undeniable, irrefutable proof of this extra unseen mass. Moving on to Suspect 2, dark energy. Discovered in the late 1990s through exploding white dwarf stars, this force is an even more mind-bending substance. These two forces are basically polar opposites. Dark matter has real mass, right? It pulls galaxies together and acts as our galactic glue. Dark energy, on the flip side, is more like a virtual vacuum energy. For a really long time, cosmologists just assumed the gravitational pull of all the matter in the universe would eventually slow down cosmic expansion. But those white dwarf star measurements we just mentioned, they proved the exact opposite. Dark energy is a force field that runs completely counter to gravity, actively pushing things apart and acting as a cosmic expander. So one pulls, the other violently pushes. And right now, the push is absolutely winning. The universe is expanding faster and faster. The plot twist: black holes. Because every great detective story needs a plot twist, right? Could black holes, those destructive portals to hell, finally captured on camera back in 2019, could they be the answer to our missing mass? See, for decades, black holes were just these theoretical realms where standard physics completely broke down. That is, until that Event Horizon Telescope image finally gave us a tangible look at them interacting with matter. So naturally, scientists started wondering, could our missing dark matter just be a bunch of tiny black holes? The legendary physicist Stephen Hawking actually theorized that primordial black holes, created immediately after the Big Bang, might just be scattered everywhere. Or what about rogue planets, billions of lonely nomads drifting through our Milky Way without a star? We actually know now that these rogue planets are incredibly common. But here's the ultimate roadblock. The math just does not add up. Even if we account for billions of rogue planets or hypothetical Hawking stars, there simply is not enough mass there to account for all the dark matter we need to explain our universe.
Section 4. The interrogation room. The global hunt. Since those objects can't explain it, we really have to look deeper. Welcome to the massive, modern-day global hunt to catch these elusive forces red-handed. We're currently deploying some of the most sophisticated, high-tech tools humanity has ever created just to see the invisible. One of our absolutely most powerful interrogation techniques is called gravitational lensing. Because we can't see dark matter directly, we basically have to look for its fingerprints. According to Einstein, massive objects bend the very fabric of space, which in turn bends the light traveling through it. Armed with this knowledge, incredible tools like the new Euclid Space Telescope are peering up to 10 billion light-years into the past, using this exact phenomenon as a perfect cosmic mass magnifier.
So, here is exactly how Euclid uses this trick. In step 1, light starts its really long journey from a faint, distant galaxy. Then in step 2, a massive galaxy or a massive cluster of dark matter sits right in the middle of that path, physically bending those light rays kind of like a glass lens. Finally, in step 3, that bent light reaches Earth and we see a distorted circular ring. By analyzing millions of these tiny distortions, something scientists call weak gravitational lensing, Euclid is literally mapping out the dark universe. And the structure it reveals, it's wild. It looks like a delicately spun web or, honestly, a giant block of Swiss cheese, featuring these highly dense filaments of matter separated by vast, incredibly empty voids.
Okay, so we can see its shadow, sure, but what actually is it? Well, the leading theory suggests it's an elementary particle, often called a WIMP, which stands for a weakly interacting massive particle. To really grasp why catching one of these things is so ridiculously hard, think about a simple fountain pen. If you pick it up, your fingertips interact electrically with its surface, which is what lets you touch and hold it. But if that pen were made of dark matter, you literally couldn't grab it. Your hand would pass right through it, because dark matter simply doesn't interact with the electromagnetic force. And because they are so ghostly, we have set up these incredible sci-fi level traps all over the Earth. Just look at this hit list. Underneath a mountain in Italy at Gran Sasso, scientists have cooled ultra-pure crystals to a freezing -273°C, just hoping a WIMP will bump into a nucleus and create a tiny flash of light. Over at CERN in Switzerland, they are violently smashing particles together in the Large Hadron Collider, looking for supersymmetrical or SUSY particles. And at DESI in Germany, they are literally shooting photons through walls trying to detect axions. But the result of decades of searching across all these multi-billion-dollar labs? Absolutely nothing.
An alternative theory. Are our physics wrong? What if we're basically looking for a lost earring in a giant house, and the earring was just never there to begin with?
Seriously, what if we have spent decades hunting a phantom particle purely because our foundational rules of physics are fundamentally flawed? Enter an alternative theory known as MOND, or Modified Newtonian Dynamics. First proposed way back in the 1980s, MOND suggests that, hey, maybe we don't actually need invisible glue to explain why galaxies spin so fast. Instead, it proposes that at incredibly vast cosmic distances and at very low accelerations, the actual laws of gravity just behave differently than they do here in our own solar system. Now, it's a highly debated theory, for sure, but as the search for dark matter particles consistently comes up empty, physicists are increasingly being forced to think outside the box.
So we arrive at the ultimate cliffhanger for this explainer. Were Isaac Newton and Albert Einstein actually wrong? Or, at least incomplete? Every rocket we launch and every single probe we send out into space relies completely on their laws. So to doubt them, it almost feels like scientific sacrilege. And yet, 95% of our universe remains completely hidden from us in the dark. We are living in a golden age of cosmology right now, pushing the absolute boundaries of human knowledge. So whether it ends up being a ghostly new particle, a sea of ancient black holes, or a total rewrite of the foundational laws of physics, the answer is out there waiting for us. Keep your eyes on the stars and stay curious.